So on rate of change, we have here, if z is a function of xy and z is 3x squared y raised to the power 5, find the rate of change of z when x is 3 units and y is 2 units, when x is decreasing at 5 units per second and y is increasing at 2 units per second. Are we together? Now the first thing you need to know, for you to get the rate of change, because what they want you to determine is the rate of change, isn't it? For you to determine the rate of change, you must get the total differential, isn't it? You must get the total differential. So you'll be told z is a function of x and y. So it means for you to get the total differential of z, dz, isn't it? Are we together? Dz, it means we differentiate z partially with respect to x, then we remain with the dx, isn't it? You differentiate z partially with respect to x, then we remain with dx. Then plus, we now differentiate z partially with respect to y. Are we together? You differentiate z partially with respect to y, then you remain with the dy. So we are done with the two variables. That is now the total differential of z. You differentiate z partially with respect to x, then you remain with the dx, then plus, you differentiate z partially with respect to y, then you remain with the dy. Then at the end, what do we want? We want the rate of change means with respect to time, isn't it? So with respect to time, it means we divide all through by dt, isn't it? We divide all through by dt. So you divide all through by dt. So once you divide it all through by dt, what do you see here? dz over dt is the rate of change of z, which is what they want you to determine. Are we together? Then you can see here, dx over dt is what? Rate of change of x. With respect to time is rate of change. Are we together? Then you can see dy over dt is what? Rate of change of y. So it means what we need to determine this, we need to determine these partial derivatives and the rates of change will be given, isn't it? Are we together? So let us start. The first partial derivative is here is what? You've been told z is 3. You've been told z is 3x squared y raised to power 5. That is what you've been told, isn't it? So the first thing we want is this. We want to differentiate z partially with respect to x. So can you differentiate z partially with respect to x? What do you get? Meaning only x is a variable. Anything else is a constant. So it means this y raised to power 5 is a constant, this 3 is a constant. What we are differentiating is this x squared, isn't it? Are we together? So if you differentiate x squared, you get 2x. So 2x times 3 times the constants there. We add 3y raised to power 5 to be a constant. What we are differentiating is x squared, which we found to be 2x, partially with respect to x, isn't it? So if you multiply that, what do you get with the derivative? 6xy raised to power 5. 6xy raised to power 5. You are done there. You move to the next partial derivative, which is the next partial derivative. We now want to differentiate z partially with respect to y. This, isn't it? Are we together? We are differentiating z partially with respect to, meaning anything else is a constant except y. So here is our z. So it means this 3, now we have the 3x squared is now a constant. We are differentiating y raised to power 5, isn't it? Which we get to be 5y raised to power 4. So you get our constant there is 3x squared. Then when we differentiate y raised to power 5, we get 5y raised to power 4, isn't it? Are we together? Are we together? So in the end, what do you get? What is partial z over partial y? 3 times 5? 15x squared y raised to power 4. Are we together? Then if you look at the equation you've been given, x is 3, meaning you've been told x is equals to 3 and y is 2, and you've been told y is 2 units. X is equals to 3 units and y is equals to 2 units. So what is partial z over partial x? Meaning where there is x you put 3, where there is y you put 2, because this x you've been told to take its value to be 3. Are you seeing? And this y you'll be told to take its value to be 2. Are we together? So what is partial z over partial x? Where there is x put 3, where there is y put 2. So 6 times 3 is 18, then y raised to the power 5. 2 raised to the power 5 is 32, isn't it? What do you get? What do you have? 18 times 32. 570 and 76. That is 18 times 32, isn't it? 570, 18 times 32, 576. So we found the partial z with respect to x, isn't it? Go to the next one. What is this? If you differentiate z partial with respect to y, where there is x, put the value of x is 3. Where there is y, put the value of y to be 2. What do you get? This is 15 times 9 times 16. What do you have? 2,160. We have 2,160. 2,160. So we found that. So what is left? We found this partial derivative. We found this partial derivative. So what is the rate of change with respect of x with respect to time? What is the rate of change of y? You've been given, isn't it? Are we together? You've been given. So what have you been told? When x is decreasing at 5 units per second, meaning this is the rate of change with respect to time. It is the rate of change of x. Are we together? Are we together? So what is the rate of change of x? dx over dt. Increasing means x is decreasing. Decreasing means what? Negative. So x is decreasing negative 5 units per second. Remember, these ones are also units, meaning there is also units per second. So we have the same units. There's nothing to be transformed, isn't it? Are we together? So you are done with that? X is decreasing. Decreasing means negative 5 units per second per time. Is that okay? You move to the next one. Y is increasing at what rate? At the rate of 2.5 units per second with respect to time, meaning the rate of change of y. Are we together? Rate of change of y, dy over dt. You'll be told is increasing is positive, isn't it? So it is positive 2 units per second. So per second you can see per time with respect to time. Are we together? So what have you found? You found all these values. So what you do is to substitute to get the rate of change of z, isn't it? That is what they want, the rate of change of z, which is dz over dt. So what is dz over dt? dz over dt is equals to partial z over partial x, which you found to be 576. Then it is times rate of change of x. And the rate of change of x you found to be negative 5. Remember the units are the same. These are units square because x was unit, y was unit. Meaning these are units square, isn't it? So unit square, if you multiply with a unit, you get units cubed per second. Are you seeing that? Are we together? So then it is plus partial z over partial y you found is 2160. Then it is times rate of change of y, isn't it? Rate of change of y, which is positive 2.5. So what do you get if you work out that? What do you get if you work out the 2? What do you have? 3? 2520. So we have 25